Hey folks, thanks so much for joining. Chris Neidl from OpenAir here. Great to have everybody join us today. We're incredibly excited for today's Four Corners Carbon Coalition Showcase, the very first that we've ever done, to give you a little bit of a direct insight into the incredibly extraordinary, cool projects that have been picked by Four Corners for our initial campaign and that will be supported through project. So you're going to hear from those folks in just a minute. My job as host is just to cover a little bit of the agenda, and then I'm going to hand it over to Four Corners co-founder and inaugural executive director, Ramon Alatorre, in just a couple minutes. So what we're going to do is Ramon's going to cover the basics of what Four Corners is. How did we actually arrive at awarding the winners who you're going to hear from today, a little bit about our mission and our history. And then we'll get right into it. And each of the four projects that have been awarded will have about 5 to 8 minutes to talk about their technologies, their companies, and their projects. And so we'll go over each of those one after another. Go ahead and do that. And I think, is this my last slide here? Great. So I think I'm going to hand it over to Ramon. So great. Looking forward to your presentation.
Perfect. Thanks so much, Chris. Thanks everyone for joining. And thanks to all of the grant awardees. Really excited to get to the project showcase in just a few minutes. My name is Ramon Alatorre. I am the acting director. And I do want to start with a few acknowledgements and appreciations because none of this could have happened without the leadership and participation and the support of the four local governments. That is Boulder County, City of Flagstaff, Salt Lake City, and Santa Fe, as well as the support from OpenAir and Carbon Direct. And so in a moment, I will give a short history and overview of Four Corners, but I first want to take a few minutes to define some terms and set the table. So throughout this presentation, we're going to be referring to carbon dioxide removal, or CDR. So it's important to just take a moment to say, what is that? We use the definition that is provided in the Carbon Dioxide Removal Primer, which is an excellent resource and now a textbook that is available for sale, that defines CDR as being activities that remove carbon dioxide from the atmosphere and durably store it in geological, terrestrial, or ocean reservoirs or in products. It is notable that this is different from carbon capture, which refers to point sources rather than the removal of atmospheric or legacy carbon. Capture may or may not be a good climate solution depending on the specific context, but one thing it is not is carbon removal. Furthermore, we always take a moment to pause and clearly state that nobody working in the carbon removal space considers carbon removal to be in any way, shape, or form a substitute for emissions reduction. So we absolutely must reduce emissions and decarbonize our economy as quickly and completely as possible, full stop. That said, we're not going to be able to reduce all of our emissions in a just and climate relevant timeframe. We're also going to need carbon removal. So indeed, since 2018, the International Panel on Climate Change has clearly stated and then reiterated this assessment with their summary for policymakers document, bluntly stating that all pathways that limit warming to 1.5 degrees uses carbon dioxide removal, and also that unless affordable and environmentally and socially acceptable carbon dioxide removal becomes feasible and available at scale well before 2050, pathways to 1.5 degrees C will become difficult to realize. This graph comes from those same IPCC summary reports, and though we have added the red lines to help with some orientation, and it shows that in fact, even in the most optimistic emissions reduction scenarios, the scale of carbon removal that will be required by mid-century is in the multi-gigaton per year range, or approximately the same amount that the United States currently produces every year. Furthermore, assuming we are successful in achieving net zero emissions globally by mid-century, a safe and healthy climate will require the ongoing removal of legacy emissions from the atmosphere at continued gigaton scale for decades. So for all of these reasons, carbon removal is an essential climate solution, along with reducing emissions and adapting to our already changed climate. And we need to be working on all of these together at the same time. So now to get to the Four Corners origin story. In some meaningful ways, it started with Boulder County and the City of Flagstaff in 2021, but the truth is the story goes back even further before these star-crossed local governments even began talking. In the preceding years, both local governments had begun hearing from their residents that they understood the science outlined in the IPCC reports, and that those residents wanted their local governments to take action accordingly to both reduce emissions rapidly and to support the now clearly necessary endeavor of carbon removal. After speaking for the Flagstaff context, which is where I'm from, in 2019, local community leaders drafted a 2-page climate emergency resolution that outlined a goal and a timeline. The goal was carbon neutrality. The timeline was 2030. And after gathering thousands of signatures in January of 2020, the resolution was brought to council and ultimately adopted. This newly adopted framework of carbon neutrality required that discussions happen in the community about carbon removal. What is it? How do we do it? And so staff began exploring options and looking for others that were doing the same. Boulder has their own local story, but suffice it to say that in 2021, they too were doing work to communicate that they were exploring carbon removal. However, this meet cute didn't just happen on its own. A matchmaker got involved. And members of the OpenAir caught wind of the signals that were being broadcast by each of the local governments and decided that they needed to meet. At the first meeting of these local government staffs, one thing was clear. It had been hard being single and feeling alone. So discussions of partnership and collaboration immediately began. And OpenAir, liking what they had helped to spark, figured that there must be other communities in similar situations. Next slide. CarbonDirect, a leading organization in the space, came into the fold and has provided numerous technical expertise services throughout the entire process. Indeed, CarbonDirect helped the cities to co-develop the evaluation criteria and the rubric to evaluate the proposals that were submitted by the showcase grantees that you will hear from shortly. They also provided a review of the proposals to provide the local governments with relevant notes from technical experts to help inform their final decisions. And as a quick teaser, CarbonDirect will be publishing a series of papers about these processes in May, so keep an eye and an ear out for those. In September of 2022, Salt Lake City and Santa Fe decided they too were tired of being single and joined. And with that, the Four Corners Carbon Coalition had critical mass to proceed with the development of its first campaign. So now one thing that the Four Corners Coalition aims to address is some of the fear and uncertainty that surrounds carbon dioxide removal, especially at this early stage of the industry. When taking the pulse of many in the country, it is clear that there is fear that carbon dioxide removal is going to be something that is imposed upon communities without input or agency. And so the idea behind Four Corners campaigns is to flip that script, to work with communities to evaluate local contexts and assets, to help communities and local governments to determine themes or types of CDR that would be locally relevant, and to invite those types of projects into their backyards. And so while we previously mentioned some of the IPCC language that stated that unless affordable and environmentally and socially acceptable carbon dioxide removal becomes feasible and available at scale, the goal and vision of Four Corners is to go beyond social acceptance and tolerance by helping to generate local beneficial projects that result in support and even pride when it comes to carbon dioxide removal. So Four Corners argues that support, pride, and even effectiveness will be best accomplished by working in the local context. Local leadership, local imagination, local collaboration, and local accountability are some of the keys to unlocking carbon dioxide activity that is welcome and invited and effective. So now I do need to turn this over to the grantee showcase, so I won't give the full Four Corners overview that we sometimes do. For that, please do visit our website at fourcornerscarbon.org for videos and resources. But as mentioned, one of the core functions of Four Corners is to work with communities to develop campaigns. And the focus of these campaigns is to assess local themes and priorities and to get innovative, first-of-their-kind projects into the real world by aggregating resources and funding for novel projects. To give a quick visual of what aggregated demand campaigns might look like, we might think about large projects that happen in the solar and wind industries. A central site model might look like a power purchase agreement. PPAs have been around now for decades, and distributed communities are able to aggregate their demand and resources to support a single large renewable energy project. And an interesting note, the first PPA was undertaken by a local government school district in California. So just a wink to the value of early local government action. A second style could be the distributed project sites that offer another aggregated demand framework. Indeed, this is the framework that was pursued for the first Four Corners campaign. The four communities put out requests for proposals and supported multiple projects that were distributed within the local communities and the region. The first Four Corners aggregated demand campaign was launched in October of 2022. The ask of the four communities was for projects that integrated carbon dioxide with concrete. And why concrete? Well, there are many reasons. Not only is it the most common building material on Earth, after water, it is the second most commonly used material. It is also a carbon-intense industry, accounting for about 8% of total emissions worldwide every year. So addressing the concrete industry has huge impact potential. Concrete is also inherently distributed in a locally produced product. So the project supported by this first campaign could be easily replicated all across the country and the world. So without further ado, let's move to the project showcase portion of today's program. Here you will see the basic flow of the presentations that will follow. The companies and the project teams will introduce themselves. They will give an overview of their anchor project or the project that has already received funding, and then they will describe their vision or ask for a multiplier campaign. Each project team has a request or a call to action that will help them to expand their impact. And so I will turn it over to the first project team, which is Blocklight in collaboration with CarbonBuilt, air capture, and one other that you'll hear about shortly.
Great. And just before the team jumps in and describes, I do want to give an extra absolute special shout out to Susie Strife and Nicole Antonopoulos. When Ramon talked about that first meeting there, the key people was Nicole, who was Ramon's colleague, the director of sustainability at the city of Flagstaff, and Susie Strife, who is the director of the Office of Sustainability, Climate Action, and Resilience in Boulder County. And without their vision and leadership and hard work, zero of this would have happened. So just want to give a huge shout out to both Susie and to Nicole.
I'll introduce myself first. I'm Ryan Ross. I'm with Blocklight. We are a locally owned and operated block manufacturing company. We are partnering with both CarbonBuilt and Air Capture in this project.
And I will go next. I'm Cindy McLaughlin. I'm the head of product at CarbonBuilt.
Hi, everyone. I'm Rob Fraley. I run business development for air capture. We're developing modular direct air capture systems for use in industrial processes.
So a little bit about Blocklight, third generation family owned and operated. We've always had high value on sustainability and just being good stewardships, being good stewards with what we've been given. We are the first block manufacturer in Arizona to embrace solar, and that we're using that for our primary energy source. I just wanted to give a shout out and a thanks to the Four Corners Coalition, putting this project together, and in all honesty, spend the rest of the time letting you guys talk to CarbonBuilt and air capture so they can kind of show you the technology. But we're excited to be part of the team and excited to be with our partners here.
Great. And I will jump in. I'm Cindy. I'm from CarbonBuilt. We enable the production of ultra low carbon concrete. And in just a minute, we'll show you a video about, who we are and what we do. But I also wanted to just jump in and shout out the Four Corners Carbon Coalition and Ramon for all of his hard work. Chris and OpenAir and Carbon Direct have all been amazing partners. So thanks to all of you. And we're thrilled to be working with Ryan at Blocklight and Rob at Air Capture.
Concrete is the most abundant man-made material, responsible for nearly 10% of total global carbon emissions. Traditional concrete is largely composed of sand and gravel, but its enormous carbon footprint is driven by the production of cement, which is the glue that holds everything together. CarbonBuilt's ultra-low carbon concrete technology enables concrete producers to remove traditional sources of carbon emissions and store waste carbon within the block. Depending on the type of concrete product being made, we can reduce carbon emissions by 70 to over 100%. With our patented approach, we can do this profitably without compromising price, performance, or plant operations. Here's how it works. First, CarbonBuilt replaces the cement with low-cost, calcium-rich waste materials, thereby avoiding the carbon emissions associated with cement production and recycling local industrial waste to avoid landfilling. Then the concrete is pressed into shape and hardened or cured in a chamber. But instead of curing the traditional way, using steam generated by carbon-intensive natural gas, CarbonBuilt cures with carbon dioxide at ambient pressure. The calcium-rich waste materials react quickly with the carbon dioxide, mineralizing it into calcium carbonate, or limestone. This both hardens the concrete and stores the carbon dioxide permanently. Plus, we use much less water to cure. The carbon dioxide we use for curing can be sourced locally and doesn't need to be purified. Thanks to our innovative approach, our concrete blocks have a lower production cost and result in a dramatically reduced carbon footprint compared to traditionally made products. CarbonBuilt's technology is flexible and customized to meet the needs of each of our concrete producer partners. We source our materials and CO2 locally. Our curing system is made from off-the-shelf equipment that can easily be retrofitted into existing masonry plants. And all products made with CarbonBuilt technology are rigorously tested to ensure code compliance for strength, durability, and overall performance. Make an impact today with ultra-low carbon concrete from CarbonBuilt.
So that's an overview of how we typically work. And in this case, we're very excited to be able to use on-site modular direct air capture in collaboration with Air Capture. So I'm going to turn the floor over to Rob to tell you a little bit about his company.
Thank you, Chris. So, hi, everyone. So air capture is, our focus is using direct air capture technology to provide CO2 into industries that are already using it. So, for example, beverage carbonation, indoor agriculture, dry ice, other applications, but also for an emerging set of new applications like CO2 to concrete. And the benefits of, so we consider direct air capture as kind of our enabling technology, but really, we consider ourselves a competitor in the industrial gas industry. Those are our companies that we have to compete with because they're the ones providing CO2 now to those customer bases. But so we basically will build these small machines, which you'll see it a rendering there, and we can actually, that unit will do 100 metric tons of CO2 removal per year from the atmosphere. We can connect, new number of these systems together at a customer site and pull the carbon dioxide out of the air at their site. These systems will concentrate it, and then we can provide it to the customer either in gaseous form, which would be the case with this project, or we can liquefy it for applications like beverage carbonation that require more higher purities of CO2. And so the benefits, as we talk to customers for projects that we're working on and prospective customers, what I'd say that they're most excited about really is the reliability that this offers, because applications like beverage carbonation and dry ice, like carbon dioxide is a critical component. Like it's not a very large percentage of the raw material costs, but they absolutely cannot do without it. And this CO2 as a product has undergone some supply chain disruption in the last couple of years. It actually happens all the time, but it's gotten a bit worse in the last few years. So what we really, what they get most excited about is the ability to get the CO2 reliably, because that helps them to plan their production and their future growth. They can count on getting the gas when they need it. So that's quite important. Obviously, we aim to be competitive on price as well. And the main reason is that despite the fact that it's desirable to use CO2 as as an input, for atmospheric CO2 as an input into products because of the decarbonization effect that it has, the reality is that most products that use CO2, even from direct air capture, are not going to trade with what we call a green premium. So they're not going to trade, they're not going to sell at a higher price than the products that don't contain that, just because that's not what the market really, that's not where it is right now, at least. So we have to count on the fact that, they're going to pay, the pricing will remain the same. So we have to be competitive on the pricing. So, and then we also reduce emissions, scope 1, scope 3 emissions. We avoid the emissions resulting from the production of the CO2 that ultimately, is what's sold to these companies, and all the road transportation or seaborne transportation. So we have an animation here This is on our website, but it's an animation of how the process works. So basically, you've got a fan that's moving very fast. It's drawing air into the side. Those little dots are some CO2 molecules and others in there, but it basically it gets the CO2 binds with a solid amine sorbent that's coating the channels of these contactors. This cube you see there, we call them contactors. The CO2 kind of sticks in there, and then it's released using steam into another chamber, to very high concentration, like 98, 99%, and can be used in a number of applications. So that's, I'd say that's kind of an overview. Not sure if I hit my time limit or not, but that's, I think that's enough for now on air capture. So this is a nice graphic that was put together, and it just shows how the process is going to work. So we're going to capture the CO2 from the air at the Blocklight site. There'll probably be 6 or more of these machines there, and it'll be processed. There should be minimal amount of processing because it comes out, and we will provide the specs that CarbonBuilt requires, and then it will go into this a curing chamber, as Cindy mentioned, or was mentioned in her presentation, for use in curing the blocks. And so it's a really elegant solution. Everything kind of connects together in the right way. So obviously there's huge environmental benefits to the project. We can avoid between 2,000 and 3,000 tons of CO2. And remove another 500 tons of CO2 from the air per year. The one thing I want to just emphasize a little bit, though, because I don't think it's talked about nearly enough, is that people talk about the environmental benefits, which is great, but like if we're not successful economically, then there won't be more projects like this, and there won't be the opportunity to to really make an impact. So the driver here really is, CarbonBuilt's technology, which saves significant costs, raw material costs, and gives, their block plant customers a real advantage in the market and makes them more competitive. It's those innovative technologies and products like that are great drivers of growth, but for businesses, which is obviously going to result in more jobs. So I'll let Ryan talk to like his plans. I don't want to make any promises that he can't keep, but I think it's what really excites me about the project, in addition to the environmental benefits, is the fact that that we're doing something that is actually going to have a real economic benefit, both to Blocklight and to their prospects for growing and hiring more people and just everything that kind of goes from that. And so it really is a result of like finding a great and really cohesive unique partnership amongst the 3 companies. So Ryan, I don't know if you have anything you want to add before we move on to Habitat for Humanity, but
Rob, I think you hit the nail on the head on that. This is a solution that makes both business sense and environmental sense, and we can actually bridge those, what seems to be like a gap, together, and will honestly be one of those things that is not only sustainable for other reasons, but businessly, it'll be sustainable and allow us to actually increase production lines and things like that. So I do like how you pointed that out. It's really made this partnership very unique, I think.
Yeah. So what we're in addition to those environmental and economic benefits, we're also very gratified to be able to do something that can actually provide a positive impact for the community, the local communities as well. It's by doing a project that gets good press and other kind of positive public feedback. What we really want to do is capitalize on that in order to inspire action. And in this case, so it was what we call our multiplier effect. And in this case, what we would be looking to do is to provide ultra low carbon concrete blocks to Habitat for Humanity of Northern Arizona to build affordable housing. So basically, what we're hoping to launch here is the fundraiser for the production to pay for the production of these blocks up to $100,000. And you can see what we encourage everybody to do is go to the fourcornerscarbon.org website. There'll be more information there and a link to be able to donate to this very worthy cause.
Excellent. Great. Well, that's phenomenal. And I think one thing that may have been left out, that this project, unless it was said, is the first of its kind in the world. So I just want to be very emphatic about how significant this project is. I also want to say we're going to go a little bit over the hour just to make sure that we get everybody in. All right, great. So now we are up to Minus Materials. Sarah joining us from Minus Materials. Hey, Sarah.
Hi, everybody. Great to be here. So I'm Sarah Williams with Minus Materials. So I'm the CEO and co-founder of Minus Materials, and I'm super excited to be here today talking about our anchor project with the Four Corners Carbon Removal Coalition, as well as our multiplier campaign. So Minus Materials, we grow biorenewable carbon negative minerals using microalgae, specifically limestone. So Portland cement production, as you guys know, is responsible for about 8% of global CO2 emissions. And the principal feedstock material is limestone. So what we do is we grow a more sustainable biorenewable carbon negative version of that feedstock mineral. So to introduce our team, I'm Sarah, I'm the CEO. I have two co-founders. My co-founders are Dr. Will Shrubar and Danielle Beatty. We are all spun out of the University of Colorado Boulder. Will is actually a tenured professor at CU Boulder. We also have Dr. Nilanjana Mazumdar on board, who is a phycologist with specific expertise in scaling up algae cultures. So going to be very key to our effort here to create a regenerative limestone quarry pilot in Boulder. And we also have a couple rockstar scientific advisors. We have Dr. Mike Garnieri from the National Renewable Energy Lab and Dr. Katarina Alves de Souza from the University of North Carolina, Wilmington. So just to get down to the crux of our project and what we're trying to do, we're essentially reimagining the way that we source raw materials to make Portland cement. So for about at least 6,000 years now, we've been quarrying in much of the same way, in that we go and we blast large sections of rock, and then we dig them up and we crush to a very fine powder. And in the case of Portland cement, that fine powder is then fed through the kiln where it's calcined, and a lot more CO2 is released in that process. So at Minus Materials, we are building regenerative limestone quarries where we're growing a carbon negative limestone product with calcifying microalgae. And what this does is it enables non-renewable geological limestone to remain undisturbed in geological formations, therefore continuing to store carbon. Yeah, so why biorenewable limestone? So limestone quarrying is a very controversial practice across the country and the world. We had quite a lot of news in our local community of Boulder over the past couple of years in limestone permitting for a major cement plant. And there's multiple situations across the country of cement plants that are set up to continue their given production volumes, but they are having trouble getting their permits renewed, often for good reason, because there have been violations or because of pushback from local communities that are unhappy about not only the carbon impact, but the impact to land use patterns, as well as impact in biodiversity of local communities. As when you're going through and quarrying land, you're really destroying a lot of that stuff. So we grow this limestone. Our limestone can store about 44% of CO2 by mass in a durable mineral form. And another key benefit is that we have this major CO2 benefit. We're obviously removing carbon dioxide removal technology. But we also reduce reliance on quarrying, which has a lot of benefits for biodiversity as well as land preservation. So some key facts about this specific pilot project. We are doing a rather small scale, but super impactful demonstration. We hope we're scaling up to about 1,250 liters cultivation, continuous cultivation over a couple of months will yield us close to 1 ton of limestone. And then the resulting limestone will be used as a filler in Portland limestone cement concrete. Portland limestone cement is super popular nowadays, where you can replace about 15% of clinker content with limestone, which gives you some pretty significant CO2 reductions. And in the case that our limestone is added as the limestone component, there's further CO2 reductions since we're starting with a carbon negative filler material. And those numbers are so as the cells are growing through photosynthesis, they sequester about 1.8 kilograms of CO2 per kilogram of organic biomass through just the photosynthesis. And then in terms of the mineralization reaction, where they make limestone, they sequester about 0.4 kilograms of CO2 per kilogram of mineral limestone produced. And then finally, to announce our multiplier effort, we have simple requirements for feedstocks, but in order to scale the way that we want to supply limestone to the global cement industry, we're currently consuming over 6 gigatons of limestone globally in order to manufacture the global budget of about 4.4 gigatons of Portland cement. The feedstocks we need are saltwater brine sources, CO2, preferably waste point source CO2 rich flue gases. We'd like to characterize and test with our system, as well as alkaline waste materials that we use as a buffer in our system to grow the microalgae. So we're looking for partners, and please contact me if you are aware of any industrial waste streams that fall into any of these 3 categories, so that we could explore opportunities for testing those materials and potential co-location opportunities. Thank you very much for your time.
Excellent. Thanks so much, Sarah. Greatly appreciated. So fascinating. So we'll talk about that in a little more depth shortly. Great. So now we do have Dr. Laura Lammers from Travertine is going to be joining us and telling us about the Boulder Block Project.
Great. Thank you so much. And thank you so much to the Four Corners Coalition for creating this opportunity, and also to Chris Neidl and OpenAir Collective for really kind of broadening the reach of understanding of carbon dioxide removal technologies, because, as you said in the introduction, community-based, not only acceptance, but kind of active encouragement of new projects is what's going to make it possible to scale in place. This is a huge challenge. And so we're excited to have received a grant to test the use of our carbon negative precipitated calcium carbonate products in ASTM blended hydraulic cements, very similar to the types of cements that Dr. Williams introduced just moments ago. And so similar to Dr. Williams' approach, we're producing carbon negative calcium carbonates. We're doing it in a way that is actually inorganic. So we're not using microbes to produce the carbonates, but rather an inorganic chemical process using waste feedstock. So our company is based in Boulder, Colorado. We have an awesome leadership team, including electrochemical leadership and process engineering leadership, folks coming out of the mining and metallurgy industry here in the state of Colorado, CU Mines. My background is environmental geochemistry with an expertise in carbonate mineralization. I trained at UC Berkeley, and then I taught there as an assistant professor in the environmental science department for many years before leaving Cal to start Travertine. And so we were here building up the system in Boulder. So head to the next slide here. And an overview of our process is shown schematically here, where we're taking in waste feedstocks from critical element extraction and converting them into solid carbonate minerals for use in green cements using carbon dioxide from the air. So there are a couple of important points here. Is we're doing end-to-end carbon dioxide removal and mineralization. So our process enables us to actually directly capture CO2 from the air and then convert it to solid precipitated calcium magnesium carbonates, depending on the feedstocks. Another important point is that we're co-producing a number of products that are feedstocks for critical element extraction. And so in our commercialization approach, we're basically replacing conventional sources of extractive chemicals that generate very, very large quantities, hundreds of millions of tons of waste globally every year. And so we're cutting out those wastes and allowing for upcycling of those chemicals. And so the process of critical element extraction, for example, gets closed with respect to these. So we basically take in sulfate waste from extractive industries, convert them to solid carbonate minerals, and then do direct air capture. We co-produce hydrogen as well. So we have a number of exciting co-products. So why this approach? The rationale for getting into the extractive industries is that these industries are operating at the hundreds of millions of tons, a billion ton per year, orders of magnitude similar to the cement industry, producing waste at those scales. And so we have feedstocks for carbonate mineralization that are of the order of magnitude required to eliminate emissions for cement production, for example. And so sulfuric acid, which is the extracted chemical that we produce, today is producing quantities of up to 300 megatons per year, 300 million tons per year. And that's projected to grow significantly to 350 to 400 million tons per year by mid-century. And of course, the need for carbon removal and durable sequestration is growing exponentially as well. And so these are some of the images of some waste feedstock here on the bottom, and one of the sources of, for example, ultramafic waste that we can use. And so our go-to-market application is processing what's known as phosphogypsum, which is a byproduct of phosphorus fertilizer production. Today, the conventional process for phosphorus fertilizer production is we take the original rock phosphorus, which is calcium phosphate, react it with acid, and you end up with a bunch of sulfate waste. What we can do is take this sulfate waste, turn it into solid calcium carbonate, taking CO2 from the air, and then return that acid back such that you can continue the process. And so we can end up with essentially substantially carbon negative fertilizers while at the same time producing very low carbon intensity, potentially carbon free cement products as well. And so we can take this feedstock, turn it into those precipitate calcium carbonates for use in blended cements. Head to the next slide. So we are already operating a system that is sized to process kilos per day, essentially sequester 5 kilos per day of CO2 using waste feedstocks. And we're really excited to have materials now to test their properties, replacing natural ground calcium carbonate with our precipitated material in blended hydraulic cements. And so we're going to be taking our materials, characterizing the properties, creating blended cements, testing them to make sure that they follow the ASTM certifications for strength and durability. Another thing that we can add on to this is basically testing our precipitated calcium carbonates as alternatives to the ground natural calcium carbonate in the calcination step that actually produces the Portland cement, which could make an overall net carbon negative cement material. So if you head to the next slide. Our operations are scalable because the feedstocks are available in, again, hundreds of millions of tons per year quantities, in some cases stockpiled. The United States had more than probably 2 billion tons of phosphogypsum just sitting in piles today. And so here we are in 22-23, we have a 5 kilo per day system operating. We're in the process of building a much larger 100 kilo per day system and in engineering design for a 1,000 ton per year system as well. And we hope to integrate directly with extractive industries such that we can scale to millions of tons per year relatively quickly, because again, these feedstocks are produced in very large quantities. And so we're excited to again test our calcium carbonate precipitates as products in cements. But again, similar to the last presentation, we'd love to be operating locally. So most of the large producers of these feedstocks are large fertilizer companies, large mining companies that are operating internationally in certain parts of the United States. I think there are big opportunities in the Four Corners region. We actually do produce very large quantities of calcium phosphates in Utah, for example. There's also legacy coal plants that may have some what's called flue gas desulfurization gypsum. So we don't need any alkalinity sources, but we do need sources of calcium sulfate waste that would either come again from legacy coal plants or from fertilizer operations. So if you are aware of anyone who has ties to these industries that would give us access to some of these sulfate waste, these industrial waste feedstocks, we would love to hear from them. Thanks.
Excellent. Thank you so much, Dr. Labbers. Really, really appreciate it. Great. So we're going to move right on to our final project with Steve Heising. And this is an incredibly cool project involving hemp concrete or hempcrete by the Citizens for Clean Energy Inc. and the Hemp Collective. So Steve, I'm going to go ahead and get started.
Terrific. Welcome, everybody. Okay, I'm Steve Heising. I'm from Boulder, Colorado. I've been thinking about carbon negativity for at least 30 years. You can see that crop there and over there on the left, and that's industrial hemp, like you've probably never seen it before. Biomass is 4 times faster than trees, and it's an annual crop. And we're going to use that to build buildings. Next slide. Jeremy Stephen, contractor from Steamboat Springs, and myself. This is a 800 square foot ADU up in Loveland, the yellow one. The yellow is actually pigments that are incorporated into the lime render on the outside. The one in the foreground is a 2,000 square foot workshop, and you can see the bare hempcrete panels in the wall. There's some history of doing this. Dun Agro from the Netherlands, Albert Dun, he has 25 years experience doing this, and he's actually moving to the United States in Indiana and in Minnesota for 2 factories. He starts with the seed, he grows the crop, he harvests the crop, he processes the crop, he puts it into the wooden forms and fills it with hempcrete, stacks it on lets them cure, stacks it on a semi truck, delivers it to the job site, builds your house in 3 days. It's very cool. You guys can take a look at this and zoom in on this in the recording later and see they're quite descriptive. So we're going to reduce the embodied carbon footprint of the built environment by incorporating hemp, biomass, the hurd, the woody part, and we're going to take everything else that we don't have a market for yet, and we're going to turn it into biochar, and we're going to use that to lower the footprint of the concrete and to lower the footprint of the lime render. So here's this one was done by Marks and Spencer 10 years ago in the UK. They're building a 200,000 square foot retail location, and they're using hemp panels, and there's some hempcrete, and there's some hemp wool insulation, and there's some other layers. But it's not like we can't do this. We've been doing it for 30 years in Europe and 10 years, and it's taken a while to catch up. So made in the factory, delivered and assembled. Shipping can be a problem. Big cranes are expensive. So this project is going to build a 2-story tip-up biocrete. I don't use hemp when I'm talking to bankers or insurance guys because they think I'm going to be some kind of a doper, not a roper. So we're going to build a 2-story warehouse. We've done a couple of them before. We have been advancing a tip-up process where we lay down the 2x4 frame and then pour the hempcrete into the form, let it sit for 24 hours, tip it up, let it cure, start again. And we've been able to do it in an off-site location and truck them to the site. And we've also been able to just pour them on site. And much of that is weather dependent. We really don't want freeze thaw taking place. So if we needed to build all winter long and build panels to assemble on site, we could do that in a factory someplace locally. Even an old horse barn would work. We had biochar. Biochar is the carbon in the hemp plant that if we pyrolyze it, which means cook it without oxygen, we can drive off the syngas, we can drive off the liquid bio oils, and we end up with carbon at the end that transformed itself from long chains of cellulose and hemicellulose and those things into more graphene and graphitic type ring structures, which are very strong. We know from the literature that if we put graphene in concrete, it makes it 30% stronger. If it makes it stronger, we could use less of it, I think. So here's the first panel. We're framing it, we're pouring it. You know, it's pretty crude. There's a big pallet's worth of body chanvre from France, which is building certified for use with hemp and hempcrete construction. That's how we got our engineer to sign off on the deal. Next slide. There's the form filled with hempcrete. And we're tipping up the first one, and heck, it's working. So far, so good. Only 26 more to go. And here we're actually, after having trucked them across the state, and Glenwood Canyon was closed, so they actually had to go through Wyoming to get here. And I would never recommend doing that, but of the 27 panels, only 3 of them had any damage. That first panel that we made, by the way, actually disintegrated when we put it up. We didn't have enough binder in the water mix. And so we fixed that pretty quick. But, you know, not everything goes right the first time. And then pretty soon you end up with ready to start putting your trusses on. So here we are building the 2-story one. The last one was the 1-story ADU. And this one, hemp comes in these big super sacks, and you can see a 2-bag mixer sitting back there that broke about 2 weeks into the project. Then we used a regular mortar mixer, and there's forms laid out on the deck, and we're filling them, getting ready to pour them, stand them up. Here we go. We can stick them up with a telehandler, and you don't need a huge crane. And this thing was an awesome piece of equipment, and we brace them pretty good because we don't want the wind to tear them. They're still pretty raw. They're still pretty wet. They need to cure for a while, but we've got, you know, we can get them up and standing, and we can start putting the trusses on and get everything tied together, and they'll still cure just fine, especially in arid Southwest. This is up in Loveland, Colorado. Next, okay, our goals are to make healthy carbon negative building technology disruptively affordable, as in maybe half the price of what things are now, because every town I've ever been to in the West, everywhere, I guess, has an affordable housing problem. And anymore, we're getting to the point where we're having an affordable food problem. And we have this carbon problem, and I think we'll see that with the industrial hemp, we can address all 3 at once. We want to make the whole building carbon negative, and we want to make it cost less, so we don't have affordability issues. And we want to address multiple problems simultaneously. And so that's what we're up to. Next slide. The thing we would like to do if we were to have more funding would be to develop, to get a larger mixer that has a belly dump, so we can. It takes 10 batches about to fill one of those forms, and it'd be nice to take 4 batches to fill one of those forms. We would like to develop some aluminum concrete forms or hempcrete forms into in a lifting jig, so that we can make this process faster and less labor and more likely to be done correctly the first time. And we had originally asked for $60,000 for a French 3cm hempcrete spray machine, which actually mixes the hemp hurd and the lime in the air as it hits the wall. And that could be, I went to Europe and saw it in action, and that could be game changing. But in terms of things that would be really useful, the forms would be really nice, because we could use the forms, and then we could move the forms on to another job and another job. And if you wanted to build this way, we've already built the forms, and you could get some forms and you could do your own building. So here's Jay Earhart and Will Schrubar and some of the building professors at CU, and we see this carbon negativity of hempcrete, and we see, yes, the lime has the purple arrow going to the right. Yes, the lime adds carbon, and then the hemp has it took more carbon out of the air, so that the whole thing becomes negative. And my question is, what if we were to be able to make the lime in a carbon negative way using some of these other concrete technologies? That negative line on the hempcrete would be even twice as much carbon sequestered as possible. So the removal is done by the hemp plant and the farmer sells it to the processor, or has part of a processing plant, and they sell it to the builder. And if they can sell it to the builder for more than the cost of production, the carbon removal cost is negative. And then again, if we can build with it and get people learning, get past the solar panels from the 1980s and start with the solar panels today, this same cost curve is going to drop, and they're going to become more negative, and they're going to be So the more you build, the faster you're taking carbon out of the air. And the byproducts are, you got biochar, which has a lot of uses. And the biochar, 5% biochar in any concrete has been shown to make it stronger. And I've calculated that if I could replace 5% of the cement and 5% of the sand in a 50-pound bag of Sackcrete with 1 pound of biochar, I would reduce the carbon footprint of that concrete by 25%, which seems pretty simple to me. And that biochar is locked away forever, pretty much. And there's other uses for biochar, but what are you going to do? So hemp, it grows a lot faster than trees. It grows faster than straw, not as fast as algae, but we can do it on regular cropland. And we can do it with minimal fertilizer, minimal herbicides. And we have something on the order of 30 to 40 million acres of corn now grown for ethanol. And we think in some ways that, considering the land use changes and the disturbance, that it's much as 25% worse for the environment than just burning the gasoline. May not be good for the brown cloud in Denver, but it's, there's enough land to be able to get half a gigaton of hemp carbon removal, and another, by not using fiberglass and not using Tyvek and not using all of the stuff we use now, we could save another 3 times that much in avoided emissions. Thank you very much.
Thank you so much. And obviously fascinating. Want to thank everybody. I'll have just the panelists quickly join us with their videos and audio, as well as with Ramon. Great, excellent. So if you guys are okay, we'll take an extra 10 minutes here. We do have, Ramon, your audio on there? Great. All right. So let's just first answer the question. I know that some of the questions were already answered. Thanks for adding them in there. We do have a question from Peter Hoberg, and this is, I believe, probably focused on what Steve was just talking about. Can you compare how Biocrete compares to engineered wood products in terms of carbon sequestration, structural properties, and cost? I think that is for Steve.
Well, we use 2x4s in the structure to hold up the hempcrete. The hempcrete is not structural at this point, but it does make a walling material. So if we can get 2x4s without having to go through the gluing process, we might be able to at least not use 2x6s and 2x8s. And we're going to do them on 24-inch centers rather than 16-inch centers. And the hemp actually grows and sucks carbon out of the air 4 times faster than trees. So you can get 20,000 pounds of hemp out of an acre with that 24-foot hemp plant. You can replant that acreage again next season with wheat and get 20% higher wheat because of the way the roots of the hemp break up the hard pan and do some things in the soil. So the cost of the hemp is only going down because it's been unknown and unworked on for the last 75 years, and it wasn't until 2008, and then the hemp rush got off on the wrong foot with the chasing drugs and chasing dope and not rope. But we believe that the farmers need this. The ethanol, what are you going to do? Electric cars don't use ethanol.
Steve, what I'll do is Peter, who asked the question, is a very active member of OpenAir, so I might just connect with you separately because he might even have some more questions about it.
Look this up.
Great. Well, what I think we could do for time, Ramon, if you think this is good, because we don't have a lot more time. And again, we'll send out the video for everybody for this weekend, along with links to each of the companies that were featured here. But I think what might be an interesting way to end off is I'm wondering if any of our awardees here, having watched the other awardees present on their technology, if there's anything that anybody wants to offer, either a question or a pat on the back or any kind of statement, I think would be welcome. There you go, Laura. I see a hand up.
I thought Steve's presentation was amazing, and I was just about to text you a question. Can you use lime instead of Portlandite, the calcium hydroxide, or do you need to start with Portlandite?
We definitely use hydrated lime, and we have the Body Chambre has a little bit of Portland cement and some other additives to give it a quick set. But we definitely use lime. So if you can make cement out of this algae process, or if you can make cement, you could make lime. Just don't cook it so far. And then if you wanted to cook it, you could cook it with the syngas and the surplus heat from the biochar process. And so we can make a carbon additive that makes the concrete stronger, and we can use the heat to make a biofuel source for the we didn't get a chance to go over that biochar slide, but it's showing, and you guys can pause the video and take a look at that. It's pretty interesting. You can also do combined biochar and power and have a generator that could make biochar and heat while you're also making electricity out of the waste from the hemp field, if there was such a thing as waste from a hemp field.
Yeah. So Laura, it sounds like you're talking about you're linking this up to what you're doing, I presume. It's not.
Yeah, I mean, I'd love to reach out to you.
Great. Anyone else on the panel have anything to say about the other presentations?
So I will just say I'm so impressed with all of you, and it's so awesome to see so many smart people tackling foundational material science challenges. So thank you, and huzzah.
Yeah, absolutely. I just wanted to say I was great listening to everybody, super enlightening. I think especially the Travertine presentation, I think we're doing a lot of similar things. So it would be great to link up and talk about our technology, and just super inspired by the cooperation between Blacklight and CarbonBuilt and air capture. I think we all know how important these industrial partnerships are going to be to these big solutions scaling. So it's great to see you guys having a working partnership together like that already.
And even speaking to that, if you guys are looking for more industry partners in the block field, I know all those guys, right? We all work together on the national and the state level. So if you're ever looking for partnerships in even the Colorado area, I can probably put you in contact with the right people. So feel free to reach out on any of that.
I love it.
I might actually elevate the question that you already answered in the Q&A, because it seemed like, we've got a lot of scientists here, and you're like the business guy. Can you speak a little bit to your just impression on like what the industry is like seeing with some of these opportunities? Are you like the fringe, or is it going in this direction?
I think I don't know if I'd say that I think we're early, right? I think we're early, but I see the direction going that way. There's a whole bunch of studies going on about carbon sequestration actually taking place inside a block, right? They're doing those studies right now and seeing that happens naturally. The industry sees the push for the carbon reduction. I sit both on a state chapter and a national board, and these are things we talk about. I think I truly believe that we'll be early adopters. And I think once we can push that proof of concept, that adaptation is going to happen, because it makes sense on all the fronts. It's holistic. It makes business sense. It makes sense to communities and what people are pushing for. So, yeah, I think, don't get me wrong, we are an old industry. We have had antiquated technology, but I think that's starting to change with the newer, younger generation, more embracing the new technology and things going forward. So I think it's going to take some early adopters, but I'm optimistic that it's going to be a big change, at least for the block producing industry.
Great. And maybe Ramon, if we want to, we can end with a closing statement from you, but I will just say this is the beginning of a relationship here. You can already hear a conversation between our partners here. And the whole point of Four Corners is to get things going. And as you can see, we're doing it here. And Ramon, maybe in your closing, you can talk a little bit about what's next even for Carbon Four Corners, because this isn't the only project. We're already actively looking to the next campaign. So go ahead, Ramon, I'll hand it off to you.
Yeah, no, that's exactly right. You set me up pretty well, Chris. Certainly part of the Four Corners thesis is we want to support getting first of their kind projects on the ground and deployed, and then we want to tell the stories. So thanks to all the panelists who came here to tell the stories, to be able to share what their anchor project was and sort of their vision for being able to expand. If folks are interested in supporting any of these expansion efforts that were outlined today, once again, the way to do that is to go to fourcornerscarbon.org. There, within the next week, we will have links to be able to send people places. Clearly, there were 2 projects where there was some additional funding that was being sought, and so there will be links to pages on the platform known as Fundraiser. Folks are probably familiar with Kickstarter, but it's very similar in nature. And so we're looking to support those projects to be able to achieve additional funding. They've already got funding for their anchor projects provided by the local governments in sort of the initial round, but we're really excited to help them be able to expand and multiply their efforts. So go to that website and everything will be directed in that way. And then also, we are really we're excited to continue to do this. We think of this as a campaign. It is a first campaign. We'd love to do a half dozen more campaigns in the next year. So we're excited to connect with other communities. So if you are a community that's got citizens, residents like Flagstaff and Boulder did, Salt Lake, Santa Fe as well, that are saying, hey, like, we know that we need to explore carbon removal. Lots of local governments, they're used to reductions. They've been talking about adaptation for a little while. Carbon removal is pretty new. So if you're a local government that's trying to figure out, like, how can we approach carbon removal? How can we explore carbon removal? We're looking to be that resource where people can go and learn and kind of think about the opportunities that might be available. I can tell you that Flagstaff and Boulder and the original groups here, they didn't anticipate that this would be the outcome when they first started exploring. And so they're very excited that this has been the outcome, and we'd love to work with other communities to launch next campaigns. We do have some exciting ones that are sort of an early conversation, but like I said, we don't want just the one or two that we're working on now. We'd love to have half a dozen more. So just kind of a general clarion call to get in contact with us. Again, that same website, there's a contact us just sort of form, and we'd love to be in touch and start to talk about theming and start to make connections and be ready for the next half dozen campaigns.
And those are communities anywhere on the planet. It started here in the West, and we're going to do more here in the West with the same original partners. But if you're anywhere in the world and you think that you're interested in finding out more, let us know. And just to close, I will say, as Ramon said, that we had really high expectations coming into this about what this would look like, and our expectations were absolutely blown away by the companies that you saw here today. This is exactly what we hoped for and more. So keep your eyes here. Video will go out tomorrow along with links to every company, and hope to have some of you involved. And thanks everybody for joining.